Hello everyone and welcome back to Level Up STEM for our Calc practice problem series. This problem is going to be about graphing critical and inflection points, and make sure to like and subscribe. So here's our problem setup. We have a graph of a function little j of x is shown below, and that shaded region A has area 2, okay, that'll be for later. And on the axis provided below, which I'll show in a second here, sketch a well-labeled graph of an antiderivative of big J of x of little j of x that is defined and continuous on the interval -5 to 3, which is in the same interval as shown, and that satisfies j of 0 equals 1. So that's our first point, which is pretty important. And now be sure that you pay close attention to each of the following. The value of big J of x at each of its critical points and inflection points, okay? So all this is saying is basically just graph it accurately. And now one thing I like to do is, I think thinking of it as like little j of x and big J of x is confusing to me. So I make sure I just mark it as f prime and f. I don't know, that's just easier for my brain to conceptualize and just do whatever you feel comfortable with, I guess. So let's graph that first point that I was saying, j of 0 equals 1. So there's that. And now from here on out, we're going to be going based off areas, right? So if we're reading left to right, our first area here is going to be an area of 1, because that's basically this little triangle right here has an area of 1. And so that means we should go increase by 1. And at the end of this little part of the graph, so that's x equals 2 right there. And again, we're increasing from 1 from where we already were. So that's there. So there should be a point at 2, 2, and there is. Now for connecting these 2 points, we can see that the y value here is positive, but it's becoming more negative, right? So we should have it being positive and kind of flatten out to that negative curve right there. Boom. And for our next little portion here, this area is 2. So by the same logic, we should be increasing by 2. So we go from 2 to 4, because that's plus 2. And that same, just x value is 3. So yep, we should have a point there. And yeah, it's starting out at 0, 0 slope and becoming more and more positive, as shown by this little portion right here. So now this is where we have to start thinking that we're reading right to left. So basically the logic is backwards. So this area right here, we have 2 full squares and a value of 1 under this little baby triangle right here. So that's a total of 3. And it ends at -2. So because we're reading right to left, we actually have to go down. Even though it's positive, it's kind of backwards logic since it's the opposite direction. So we're going down by a value of 3 because that's the area. So we go from 1 to 0, 0 to -1, -1 to -2, and that x value is -2. So we should have another point right there, and we do. And so this slope, if we're reading back to left to right, is starting out really positive, and then it becomes less positive. So it should pretty much be the same type of behavior as the other one. Yep, there you go, right there. And so for our next point of interest seems to be this -4 value, since something happens in the graph here. And at this -4 value, remember, it's still -4 because that just stays constant. The x value is constant. And between -4 and -2, we have an area of 3. And this time it's a negative area, but we're reading right to left. So that means we actually increase. So we should have a point increasing by 3. 1, 2, 3, and at -4. So we should have a point right there. And we do. And now for this slope, back to reading left to right, it starts pretty negative and becomes more positive. So that should be reflected in here. It starts out negative and becomes more positive like that. Yep. And this last little portion is just a straight line with a slope of -2. So if we're starting up here, our slope should be -2, just like that. Yep, and so there's that graph. In terms of finding the inflection points and the critical points, Those are those values right there. And I guess the critical points can be found just based off of max and min, or where the slope of that point would be 0 or undefined. And so the slope here is pretty much undefined since because of that sharp edge. And also here, the slope is 0 because it flattens out, as you can see. And now the inflection point is a little bit trickier. I put the definition there to help us. A point where there's a change in curvature. And so as you can see, the only place this changes in curvature seems to be right here. It's concave down here and then concave up there. So we know -2 is a inflection point there. And also you can see the change in concavity there. Yep, that would be another inflection point. So in this case, the inflection points and the critical points are actually the same values, which you'll see from time to time. Okay, and that's the end of this problem. Make sure to like and subscribe.